Welcome to video 5.2 over the different types of chemical reactions. In this video, you're going to learn and to see the 5 different ways that chemical reactions occur. Also, you're going to learn how to evaluate and to determine from a chemical equation what chemical reaction is occurring. So in this video, we have 5 vocabulary terms, which are the 5 different chemical reactions we're going to look at. So as we get started, we can see these 5 different chemical reactions. We have synthesis, decomposition, single displacement, double displacement, and combustion. So a quick review or a quick reminder, a chemical reaction is whenever an element or a compound or some combination of element and compounds are chemically transformed into some new product, into some new element or some new compound. So as we go through here, pay attention to the different chemical equations that I give you, because your number one job from this video is going to be able to recognize and identify the different chemical reactions based on their chemical equation. So here's the first one, the synthesis reaction. This is also sometimes called the combination reaction. You will notice a synthesis reaction will have 2 or more substances coming together to form just one product. So an easy way to recognize a synthesis reaction is there will only be one product form. If there's more than one product, you know it's not going to be a synthesis reaction. So here in our generic equation, we have A plus X to create AX. And the actual example of this would be when magnesium reacts with nitrogen gas to form magnesium nitride. So again, how do I recognize this is a synthesis reaction? Because there's one product. But really, what's the definition of it? You have 2 or more atoms come together to form just that one product. Easy way to remember that a synthesis reaction is to make something is that's what the word synthesis means. When you synthesize something or when you wear a synthetic material, it means something was created, something was man-made. So a synthesis, synthesize, these are synthetic. These are all the concept of something is being made. Here in a synthesis reaction, we are making one compound. The next kind of reaction we look at is actually the complete opposite of a synthesis reaction. That's a decomposition reaction. Before, we had multiple reactants come together to make one product. But in this example, you can see a decomposition reaction is where you have one reactant, you have one chemical that is going to be broken down into 2 or more simpler substances. So here's the example of calcium carbonate, how it decomposes and breaks down into 2 different chemicals, calcium oxide and carbon dioxide. So how do we recognize decomposition reactions? There we only have one reactant and it makes multiple products. And so now we're going to get into what's called the single displacement reaction. Here in our single displacement reaction, you're going to see that one element will replace another element in a compound. This is kind of like when there's a guy and a girl walking down the hall. We'll give the guy the B and the girl the X. And here comes along another studly guy who steals this guy's girlfriend. And so what's going to happen in this single displacement reaction is A is going to take the place of B. A is going to steal the relationship B has with X. And so here again, a single replacement is when one element replaces another element to now create another individual element as a product by itself and some new compound. So here's an example of zinc cation reacting with copper chloride. And zinc is replacing copper to create zinc chloride. And now copper is left all by himself, let alone on a date, going home empty-handed. Now notice here, you can have either anions or cations taking place in a single displacement reaction. So when we have our individual elements by itself, you have to think back to what kind of anion or cation would they form. Zinc, when he goes into a compound, it has become positively charged. So he is going to replace the positively charged copper here. Bromine, when he goes into a compound, he's going to be negatively charged. He's going to be an anion. So in this situation, bromine is going to replace iodine on this date. So again, the idea here is one element replaces another element to create a new compound and some other element by itself. Remember, your job is to be able to recognize and identify these. If I gave you the chemical equation, and you can recognize it as single displacement in this situation. So the next kind we got, I call it the double displacement reaction, and I even call it the double date disaster reaction. If before it was like one guy stealing another guy's girlfriend, or like one girl stealing another girl's boyfriend, this is like the double date disaster, where two couples go on a double date together and they realize that they like each other's boyfriend or girlfriend better, and they go home as new couples. So here we see two compounds form together. They switch partners to create two new compounds. Here you can see that sodium and chlorine came to the party together. Silver and nitrate came to the party together. But however, after the night ended, sodium realized nitrate was a little bit more of a better fit. Silver realized chlorine was a little better of a fit, and so they switched partners to create silver nitrate and silver chloride. On a side note, this little arrow down could also be represented by a P or a PT. You know how we did the liquid, solid, gas, and aqueous? This is a symbol to show a precipitate was formed in a solution. A little side note, we'll cover that more later. But again, the double displacement reaction. Two compounds switch partners and create two new compounds. And then the last kind of reaction we're covering is called the combustion reaction. This is where we are playing with fire. A combustion reaction, for the chemistry we're learning now, is when you have a hydrogen-carbon, you have some kind of fuel that is carbon-based, some kind of carbon-hydrogen fuel, so it's primarily carbon-based, reacts with oxygen, and it produces carbon dioxide and water. These reactions are very easily identifiable because you'll always have the exact same two products, and you'll always have oxygen and a carbon fuel present. So the challenging thing about these is not recognizing them, but this is when you go to be balancing them, you do got to pay attention to balancing them. This is often when you'll go down a rabbit hole and you'll need to double your coefficients to make it all work out. So that's practice. So again, your job from this video is to be able to identify the different types of chemical reactions. Label them. Is it synthesis? Is it decomposition? Is it single displacement, double displacement, or combustion? And then, because we're already learned it, pause the video and take time to balance the equation. So go ahead and pause the video and then come back and I'll show you the answer. But right now, seriously, pause the video, identify each of these individual chemicals based upon what we just learned, and take the time to balance them. When you come back, I'll show you how to do it. Okay, welcome back. So you should have been able to identify that this first reaction has a single element taking the place of another element within a compound. This is kind of like going to the pizza parlor where some guy's on a date with some girl and some other more studly guy comes in, takes his girl, and creates a new couple, and poor old Led is out on his own. So this is the single, and it's sometimes called replacement or displacement. Both words are used sometimes. Displacement. This next one, you can see you have one compound being broken down into two smaller compounds or elements. This is an example of decomposition. This is how we decompose water. So we should have labeled this decomposition. And finally, the last one, we can look through here. I identify there's an oxygen present. I identify there's a carbon dioxide present. There's a water present. And there's some kind of carbon fuel. So this would be labeled as combustion. So the first step of this video is, can you identify and label these three different types of reactions? Also now we want to go through and balance these. I'll show you how to balance these. The answers here was 2, 3, 2, and 3. What would I have done? I would have started with my nitrate first. My nitrate first, that's the hardest one. I have 3, I have 2 here. So I need to do that little cross idea and multiply by 3 and 2 to give me 6 nitrate, 6 nitrate. Now my aluminums have 2. My leads need to have 3. Bada bing, bada boom. here. Start with your oxygen, 1 oxygen, 2 oxygen. So I need to double this bad boy. 4 oxygen or 4 hydrogens. So I need to double that to get to my 4 hydrogens. The last guy here, start wherever you want. I'm going to pick carbon. Why not? 2 carbon. So I'm going to put a 2 here. I have 4 oxygen and 5 oxygen. I always said save oxygen for last. So let's look at our hydrogen. 6 hydrogen, 2 hydrogen. So I need a 3 here. Now let's look at my oxygen. 4 oxygen, 3 oxygens. Oh no, I have a problem. So the tip Mr. Lawrence gave me is go through and double my coefficients. So instead of 4, let's call that, instead of 2, let's call that 4. Instead of 3, let's call that 6. Now let's look at what we got. 4 carbon. I need to put a 2 here. 12 hydrogen, 12 hydrogen. Now let's go back and get my oxygen. 6 oxygen plus 8 oxygen gives me a need for 14 oxygens on this side. Quite easy video today. What you should have picked up is that chemicals can react in a variety of different ways. There are 5 different major type of chemical reactions, and you have to start to be able to identify those based on their chemical equations. Have a great day.